Hey everybody, today we're going to be talking about transformations. And transformations is just a fancy way of saying we're going to take old functions, things that we know and love, and create new functions out of them by doing something algebraically to them. Now, we're going to be talking about 5 different types of transformations. And today the way I'm going to present this is I'm going to give you, for example, the general way of doing whatever transformation we're talking about. And then we're going to go to a concrete example to give you guys that visualization. So the first type of transformation we're going to be talking about is what we call a vertical shift. And as the name suggests, what we're doing is we're taking a graph and we're shifting it vertically. We're not really changing the function all that much except for, again, just vertically shifting it. Now, how do we do that? We take our function and we add a constant on the outside. Okay, and I'm going to call this constant k. Now, if k is greater than 0, this is going to shift f of x up k units. And if k is negative, this shifts f of x down k units. So let's see this in action. Okay, so I'm going to pull up Desmos right now. Now, our motivating example, or our example that we're going to be using for this entire discussion is x squared. And I picked this because it's one of my favorite functions, but how can you not smile when you look at this function? It's just a smiley face. Now over here on the left, you're going to see different types of transformations. I'm going to give you the transformation in 2 different ways. Function notation, okay, just using f of x, and the actual algebraic notation for that transformation. Okay, so all of our examples today, you're going to see that pattern. It's going to be the function notation and the algebraic notation. You want to be comfortable with both. So for instance, let's look at f of x plus 1. So notice we're adding 1 to the outside. So what does this do? This shifts our graph up 1 unit. Okay, and again, it's not changing the function itself, it's just literally moving it up 1 unit. Okay, or it's not changing the shape, I should say. Now, what's the function notation for this? X squared plus 1, and I want you guys to notice nothing really happened because it's the same blue function there. Okay. Now, what if we had f of x minus 2? So we're subtracting 2 on the outside. That's going to bring our graph down 2 units. Okay. And again, the algebraic notation for that, x squared minus 2. And again, notice nothing's happening there. It's the same graph. So again, if you add a number on the outside, positive numbers shift up, negative numbers shift down. Okay, so let's go back to our PDF. The second type of transformation that we have is what we call horizontal shift. And I put a star next to this because you want to be careful with these. Now, how do you horizontally shift a function? Let me go and highlight this for us. You add, instead of on the outside, you add a constant right next to the input. Okay, so f of x plus h. Again, notice that the h is inside of the function. Okay, it's right next to the input. Okay. Now, if h is greater than 0, and this is where you want to be very, very careful, it does the opposite of what you may think it should do. So h being greater than 0, this is going to shift f of x to the left h units. Whereas if h is less than 0, okay, so it's a negative number, then it shifts our graph to the right h units. Again, let's go ahead and see this in action. Okay, now again, we're still looking at x squared. So notice here our first function, f of x plus 5. So we're adding a positive number, okay, to our inputs. Now what's this going to do? Again, it's going to shift our graph to the left, okay, 5 units. So again, it took our graph, it shifted it to the left. And again, here's our function, or our algebraic notation for that. F of x minus 3, so we're subtracting 3 from our input. So that's going to shift our graph, as you're going to see, to the right 3 units. Get rid of those. So again, if you add a positive number, it shifts to the left. If you subtract a number, it's going to shift it to the right. And just to show you guys, there's the function notation for that as well. All right, moving on. Now we're going to get into the stretch and compression. So now we're changing the shape of our graph. Okay, so the next type of transformation is what we call a vertical stretch and compression. And like the name says, what we're doing is we're going to be either pulling along the y-axis, so vertically, or we're going to be compressing along the y-axis, okay, or smushing, okay? Now, the way we do this transformation is we take our function and we multiply it by some constant on the outside, okay? So if this constant is bigger than 1, this is a vertical stretch. And if this constant is between 0 and 1, so it's like 1/2, 1/3, 1/5, we vertically compress f of x. So let's see this in action. Okay, so again, we're still dealing with x squared. So now if we multiply our function on the outside by 4, again, this is going to be a vertical stretch. So you're going to notice that what are we doing? We're pulling along the y-axis. So imagine you're taking your arms and then you're lifting and you're raising them up. You're stretching them. Okay, that's what's going on here. We're stretching vertically. And again, function notation for x squared. Now, if we multiply our function by something that's less than 1, okay, so let's say 1/5, you're going to notice that we're going to press along the y-axis. So imagine smushing your parabola. Okay. And again, the function notation, 1/5 x squared in this case. So again, if you multiply a number that's bigger than 1, you vertically stretch. And if you multiply a number that's less than 1, like 1/5, okay, that's a vertical compression. Now, like we had with shifts, we also have horizontal stretch and compressions. And again, you want to be careful with your horizontal transformations. Now, the way we horizontally stretch or compress, we multiply our input directly by some constant. Okay, so f of b times x. Now, if b is greater than 1, again, this is a little backwards. If b is bigger than 1, this is actually a horizontal compression. And if b is between 0 and 1, this is a horizontal stretch. Okay. Let's go back to Desmos. Okay, so notice in our first example here, we have f of 3x. So we're multiplying our input by a number that's bigger than 1. And notice what's happening to our graph. Okay, imagine we're taking our function and we're smushing it horizontally now. So imagine taking a slinky and pushing it horizontally. And notice what happened to our function. It got smushed. And again, here's our algebraic notation for that. Now, if we multiply by a number that's less than 1, so like 1/4, okay, again, this is going to be a horizontal stretch. And notice it's going to be like pulling our bars, okay, along the x-axis, or pulling our arms. Boom. And again, here's our function notation for that. So again, if you multiply your input by a number that's bigger than 1, that's a horizontal compression. We're smushing it, okay, like we have here with the black graph. Okay? But if you multiply your input by a number that is less than 1, okay, it's a horizontal stretch. So we're pulling along the x-axis. And lastly, we have what we call the reflections. Okay, and the two types of reflections we're going to talk about is a reflection across the x or the y-axis. Now, the way you reflect a function across an axis, you multiply it by a -1. Okay, so if we multiply the outside of your function by a -1, this reflects f of x across the x-axis. Whoops, let's not write in highlighter. Okay. If you multiply your input by a -1, okay, this reflects f of x across the y-axis. Okay, so again, let's see this in action. Okay. All right, so here notice we're multiplying our function on the outside by -1. Okay, and again, what is this going to do? It's going to reflect our graph across the x-axis. Okay, so notice we're just reflecting, taking the mirror image. And again, the function notation, or the algebraic notation for that, minus x squared. Okay. Now the parabola is kind of special, so notice what happens if we take our input and multiply it by -1, okay? Now what I said earlier, it's a reflection across the y-axis now, but if you reflect the parabola across the y-axis, notice what do you get? You actually just get the same thing. The parabola is very unique in that way, okay? But to show you guys I'm not fooling you or anything, let's go ahead and look at another function. Let's look at x cubed. Actually, to do this, let me get rid of our parabola for a second. Okay, so here is g of x equal to x cubed, the cubic function. Now, if I multiply my input by a -1, okay, like here, how we have here in 39, notice it reflects it across the y-axis. Okay, so that orange graph here is just the reflection of y, or the mirror image of our red graph across the y-axis. And here is the algebraic notation for that. So these are the 5 types of transformations. Now, you also want to be careful about multiple transformations as well, and that's what you guys are going to be doing in your activity, but it is possible to take more than one transformation of a graph. Okay, so for instance, let's go back to our parabola for a second. Let's say we took x squared, okay, and let's say we added 3 units to the input, and let's say we subtract as well. So what did we do here? We shifted to the right 3 units and then shifted down 5 units. I'm sorry, shifted to the left 3 units and down 5 units. Even professors can mix that up a little bit. So you want to be careful with that as well. We can also apply multiple transformations to a function as well.